And I hope it will not be cut into bits and pieces like it was did the other time. Nevertheless, yeah, continuing from where I stopped, which is the wide area network. And like I said, this provides no limit of distance. It covers a large area, a very large amount of area. So there are two main components of the wide area network. We have the router and we have the transmission line. So the routers are what is used to like connect transmission lines together, while the transmission lines are what is used to transmit and move bits and packets of data between a machine to another machine, a computer to another computer. So the one provides long distance transmission of data, voice, image, and video information over large geographical areas that may comprise of a country, a continent, or even the whole world. So it's possible for you to be in Lagos using MTN and you have that MTN coverage that goes as far as wide as Abuja and other geographical locations in the country. So well, in comparison to the local area network, the local area network depends on their own hardware for transmission, but the wide area network may use public links or private communication device, which is usually in combination, and it goes for over a large number of miles. So the one that is only owned by a single company is often referred to as an enterprise network. So that's that about the classification of the wide area network. You have the main goal of network. The main goal of computer network, that's the computer network goals of motivation, is that is to enable users to have access to resources and to be able to share these resources, so that you have a particular data item on a computer, you should be able to access it and get across to it. So the whole main aim of computer networking is actually data access and data sharing, information sharing, and access and sharing of these resources. Then application of network, it can be used in, we have the generic application, which is resource sharing, which is part of the main goal that I just made mention of. Also have personal communication. Resource sharing in the sense that it's sharing CPU, peripherals, information and software, sharing printers, So personal communication, that's in terms of sending text, graphics, audio, video, bytes and packets of data. And then we have network-wide information discovery and retrieval. So types of network. So here we're looking at the various types of network. So I think there are two main types that are discussed here. We have the point-to-point network or the switch network. We also have the broadcast network. So the point-to-point network consists of many interconnections between individual pairs of machines. So to go from the source destination, we have a packet on this type of network, which may have to visit one or more intermediate machine routers. And we also have the broadcast network. The broadcast network has a single communication channel that is shared by all the machines on the network. Short messages called packets of data are sent by a machine and received by all others. And address should be the packet that are specified for when it is the way it is intended. And upon receiving the packet, the machine checks the address field. If the packet is intended for itself, it processes it. If it is intended for another machine, it just ignores it. So these are the various types of network. So then what's the difference between broadcast and multicasting? This particular question was actually said in the same question of mode 1, unit 1. We have where they say when a packet with this code is transmitted, it is received and processed by every machine on the network, and this is the whole broadcasting itself. Multicasting is when we have the broadcast system that supports transmission to a subset of the machine. So broadcasting is when we have a particular packet of information that is sent across to all the machines available on a network. Let's say let's use the local area network, for example. So on a local area network, probably there are different devices that are connected to it. So the ability to actually send a packet of data from one source to all the machines that are on that network and the computers on the network, that's what we call broadcast. So that broadcasting, you can think of broadcasting in the sense of sending a broadcast message. If you have to send a broadcast message on WhatsApp, this means like probably grouping all your contacts into a particular broadcast group. Then you drop a message in that broadcast group and it gets across to everybody. So the whole multicasting is when a particular machine has like another machine under it. So it's like let's say my own machine, let's say I have a machine that's connected to the network, and there are like 3 other machines that are connected to my own machine. The ability of a particular broadcast system to actually support transmission to all the machines that are my own machine as well. This is what is known as multicasting. So the difference between them is that the broadcast will transmit to all the machines on the network, while the multicasting it transmits to all the subsets of the machine, like the machines of the machines on the network. So that's about the difference between broadcasting and
Please come again. Please, hello. Please come again about that multicasting and broadcasting. The difference, please.
all right. Like I said, so the difference between broadcasting and multicasting is that in a broadcasting system, when a packet of data is transmitted, no, it is actually sent to all the machines on the network. But for which might not include the subset of a particular machine. So when I say subset, I mean the children of like the computers that are connected to. Okay, let me quickly get my friend to see if I can do a simple um, analogy here to explain what I mean. So let me quickly share my screen and move on to.
Please let me come in here for Chuma.
Okay, but
Think broadcast like we have our WhatsApp groups for NACOS. So we drop a message there, it goes to everybody's phone, whether you are concerned or not. That is just a simple relation of broadcast. But for multicast, the way we are in this particular meeting, you can, if you observe, it's just a limited set of students, and the limited set of students are those actually doing CIT311, because we are actually subscribed to that to this vision. So the content is specific to us. You can't find it on the Mushin group. I'll be on the NACOS group. That's just what I can use to explain how broadcast is different from multicast. Multicast is information communicated set of sets of devices, but broadcast is communicated to all. Hope you get.
All right, I've gotten it. Thank you so much. I've gotten it.
all right, thank you very much, and thank you very much, boss. Um, okay, I think basically that's like the brief of everything that we have in maybe 1 minute. So, but before I just hand everything over to my boss, let me just talk about the OSI reference model. The OSI is what we know as the Open System Interconnection. The full meaning of that OSI is an acronym that stands for Open System Interconnection. So the OSI model is based on a proposal that was developed by international standard organization. So it's the first step towards international standardization of protocols using various layers. That's the various layers of the OSI reference model. So the model is called ISO as an OSI, which is like ISO is our international standard organization, while OSI is the Open System Interconnection Reference Model. That's because it deals with connecting open systems. That's systems that are ready to accept, that are ready to communicate with other systems. So the whole point of the open system connection is like having a model of data communication and data layers between systems that are ready to talk to themselves. So there are actually 7 layers. I don't know, is it 7? So the 7 layers of the OSI reference model, you have the physical layer, the data link layer, the network layer, the transport layer, the session layer, the presentation layer, and the application layer. So the physical layer is what, from the word physical, we are looking at the physical component. It defines the electrical and the mechanical specification. And when we're talking about this, we'll be looking at the connectors that we'll be using, the cables involved, and all of that physical component that links 2 nodes on a network. So we have the data link layer. So the data link layer is to make sure that the transmission of data is seamless. It's to provide error-free transmission. So it accomplishes this task by having the sender, make sure that the input data is split into different data frames, then transmitting these frames sequentially. So it's like having a huge amount of data, then breaking it into small bits so that each little bit are sent. So it's not going to be as if it's going to be every load when everything is pushed at once, but making sure that everything is pushed sequentially, one after the other. That's for the data link layer. Then the network layer. We know that our data link layer is responsible for making sure that each particular data gets to where it's going to. But the network layer makes sure that each packet of data moves from the source to the destination in an efficient manner, like making sure that it's going to make use of the best strategy or the best protocol, the best design, and making sure that this packet of information, this packet of data moves from the source to the destination. It passes and goes through each network node from one network node to the other. Then the transport layer is to accept data from a particular session layer. We're still going to look at the session layer to say one or two things about what the session layer is all about. So the transport layer accepts data from the. Yes, sir.
Are we not using anything on the screen?
The only thing I have with me now is just the course material, and if you want me to just show that to you, no problem. I will just present my screen now.
Yeah, I think we should just project so that the screen record or the screen record purpose, we can just show something on the screen.
All right, sir. Okay. Thank you very much, boss. So the 7 layers of the OSI model, we have our application layer, the presentation layer, the session layer, the network layer, the data link layer. So I'm presently talking about the session layer, the session layer, or the data layer. The transport layer. Like I said, the main function of that transport layer is to accept data from the session layer and split it up in such a way that it is a smaller unit. And if need be, it will pass this across to the network layer and make sure that all these pieces arrive correctly at the other end. So the transport layer accepts data from the session layer and it now sends this data to the network layer. So if these data are kind of like big and might probably have a problem with it getting delivered to the network layer, the transport layer attempts to split them into smaller units as well so that it gets across to the network layer. So the session layer, it allows users on different machines to establish sessions between them. So when we're talking about a session, we're talking about a particular, should I say, period of authentication and authorization. So a session might be used to allow a user to log into a remote time sharing system or transfer files between two systems. When we say we have a session, it means that for this particular period of data communication, that data is coming from user A and is going into this particular node of network. And at the end of the day, this data is going to be picked, maybe sent to the transport layer, from the transport layer to the network layer, and on and on like that. So then we also have the presentation layer. Then the presentation layer is unlike all other lower layers, they are just interested in moving bits of data from one place to the other. The presentation layer is actually concerned with the way in which information to be transmitted are presented. These are like the semantics of the information to be transmitted. So it's like a kind of, when we are talking about the presentation layer, there's some sort of standard that is agreed upon so that it's not just that people will be coming about to be exchanging random information. So it's like there's a kind of standard that is agreed upon that, this is the word you'll be using, this is the syntax you are expected to use. And most user programs do not exchange random binary bit strings. They exchange things such as people's data, amount of money, and invoices. So we have the application layer, which is the last data layer that I'll be talking about here. The application layer supports functions that control and supervise the OSI application process, which is we have a way to allocate and make sure that the resources are available to all machines involved. It also supports remote job execution like your FTP. Yeah, FTP stands for File Transfer Protocol. You also have some virtual terminals. When you are like opening up an SSH terminal, a secure shell on your computer to make some remote connections. So this is what the application layer is all about. So at this junction, I would like to hand over the reins for this class to Mr. Promise so that we can continue from here on out. So if you guys have any questions, don't hesitate to ask your question. Mr. Promise, are you here?
Yes, I'm here. Good evening, all.
Okay, good evening, sir. Thank you very much, sir.
Okay. Thank you very much, Mr. Mastercraft, for that concise revision. Okay. Adding to what he said on the OSI layers, I just want to chip in something. I know it can be quite confusing. It can be quite confusing to actually memorize all these things: physical data link, network, transport, session, presentation, application layers. It can be quite confusing. But for me personally, even I don't even carry all these things in my head most of the time. But an acronym I coined an acronym I use for this kind of thing is, okay, please do not touch Seun's presentation application. If you're able to just put down the first letters of this on paper, I believe it should be quite easy for you to now expatiate it, to put it down. And also note that typically when Adeyemo, you want to say something? I think I want to believe we should be able to understand what it is and how the OSI layers work, because this is a very, very important segment of the entire networking. Is just like the foundation for our networks today as we have it. So I want to still talk something on before we dive into the past questions. Yes, IP address ranges. You should take that. You should take that. Maybe later after the class, you can go on Google, search for this. But within IP addresses, we have C IP address ranges, and as you can see on the screen, these are their subnet mask. This net is like the divisions of the network, and within all these things, we have up to 30 bits. All subnets are calculated using they are calculated in binaries and octets. So keep that at the back of your mind. It can be a trickish question. They may not ask you this question directly. It can just come indirectly, and they are referring to this. So just keep it at the back of your mind. How many the major types of subnets we have, which is class A, class B, class C subnets. So please do not forget this part. So, okay. Now I just want to touch routing algorithms. Yes, we talked about Mastercraft. We talked about trees yesterday, right? Data trees. Are we spanning trees?
Yes, sir, that's true. We talked about that in data structures and algorithms, sir.
Yes. So you see, that plays a very, very vital role in networking, because okay, we understand spanning tree algorithm. We still employ that method within networking, and where we use it more within networking is the routing segment of networking. So within networking, we have what we call routing algorithm. Routing, that is ROUTING. Then you have algorithm, your normal algorithm spelling. Okay, I think I have that here. Yes, routing. So routing algorithm in networks is that part of the network layer software which is responsible for deciding which output line an incoming packet should be transmitted on. So let's say I have a routing diagram here. As you can see from the diagram, we have A, we have C, we have B, we have D. So it's this routing algorithm that now decides how am I able to communicate to C, how am I able to communicate to B, how am I able to communicate to D. That's what routing algorithms is. So the simple and short, it's just that part of the network layer software which is responsible for deciding which output line an incoming packet should be transmitted on. It's not that difficult, if you ask me. The thing with this exam, from what I can see on the past questions, is just simple questions, but some for those of us within the technical field, it may be quite difficult to put in words. So regardless of whether our routes are chosen independently for each packet or only when a new connection is established, there are certain properties which are desirable in a routing algorithm. And I just want to break that down. So here you have properties of a routing algorithm. It must be correct, it must be simple, it must be robust, it must be stable, it must be fair, and it must be optimal. And what do we mean by this? Okay, let me use our common everyday example. I go on google.com. I'm expecting to meet google.com on my browser. But if I type google.com and I'm seeing Yahoo, that means the route is not correct, because I believe the information I pass to my system, my system doesn't even understand it. That's just what we have for the correct points, for the correctness, which is a key property in a routing algorithm. And simple. It shouldn't take me 10 years to open a single website. It should just take me the minimum time possible to get to that point. So that routing network is simple. Let's say I'm moving from point A to point C or point A to point D. It should just take me there straight, not having to take me through C, come down to B, come down to D, and come down to this particular point where I am going to. It's not really feasible. So the route must be simple, and it must also be robust. And what do we mean by robust? It should be, forget everything. It's just grammar. It should be trustworthy. It should be trustworthy. That's the meaning of that robustness. It should stand the test of time. Yes. And it should be stable. I shouldn't be going to google.com today and, okay, for this second, I'm able to access google.com. Next second, I'm not able to access google.com. I'm rather going on Yahoo. So that's a bad routing algorithm. So my routing algorithm must be correct. It must be simple. It must be robust, and it must be stable, and it must be fair. There's what we call bandwidth time, round trip time. This is the time it takes for a packet to travel around the network. Sometimes in some textbooks you see cost. This is the time it takes for a data packet, to travel through a network tree, or as you have it, spanning tree. So if you understand how easy it is for you to do the divide and conquer algorithm in spanning trees, this is where fairness comes into play, because the time it should take me should be as short as possible, and it should be optimal, at saying it should be at its best performance at every point in time. So we have under routing algorithms, we have two major types of routing algorithms, which is the adaptive and the non-adaptive. The non-adaptive algorithms do not base their routing decisions on measurements or estimates of the current traffic and topology. And what do we mean? What do we mean by that? They don't, for non-adaptive algorithms, they don't really know if the network changed. You can, okay, Google has about 10, no, not even 10, up to 200 and 1,000 IP addresses that they use every day. But they use, it's based on routing algorithms that they now know that, okay, you are from West Africa. The server closest to you is in Ghana. Instead, go to the Ghana server, not coming down to Europe. And if your ISP, that's your network, doesn't understand that, okay, there is a shortest path to get to this point, it doesn't understand, it's non-adaptive. So if the server in Ghana is down, it will tell you it is not going through, because it hasn't learned. It doesn't have an idea of the servers in Europe. It doesn't have an idea of the servers in South Africa. So it should be able to always calculate this. So non-adaptive doesn't take note of all these dynamic changes within the network. And an example of a non-adaptive algorithm is the static routing. When we talk about adaptive algorithms, there we talk about dynamic tables. Yes, on my router, a new device comes on board today. That's my laptop comes on board. Immediately my router has picked, yes, that a laptop is on board. Okay, if there is a package sending to this laptop, okay, it already knows where it is, and it already knows how to get to it. It learns this network loop every second. But you cannot get that with non-adaptive. It's only adaptive that changes its table every second, every few seconds, because they must learn of the new network, of the network around them. It's just like, okay, someone moved into your street. Yes, I should know that, okay, I have a new neighbor. I don't have a new neighbor. That's being adaptive to your environment. So I want to believe that's for routing algorithm, the basic we can touch on it. And under routing, we have the shortest path. So I mentioned this, I made reference to this diagram sometime. Well then, within this diagram, one of the shortest things we can see here is the most important thing you can see here, which is very, very obvious, is the path between A, that's point A, and point B. Think of these devices, think of these things as computers within the network. Think of these things as computers within the network. You have, before I go on, hope we are following.
Yes, sir.
Yes, boss.
Yeah, we can hear you.
Okay. So think of this. If you observe, we have point A here. We have point C here. We have point B here. And then we have point D here. So if you notice, this first part is a triangle. The part under it is another curve. But then, given this triangle now, I'll be given this entire thing now. We think of it as a diagram. We think of it as a diagram first for going this center region. Just think of this center region as non-existent. Think of it that it doesn't exist, because this now is a loop, it's a circle. It's a circle. But then you should check if this was your community, if this was your village, and you have a brother B, and you need to pass a message across to brother B, you discover that you either have to meet C or you have to go down to D. Okay, let's say B is your cousin. B is your cousin, C is your father, D is your mother or your uncle, thereabout. But you now discover that if I needed to pass a message across to my cousin, I either have to call my dad or call my uncle to tell him, okay, please help me tell Shemilore that I need my pencil back. And you know how, in a way, you know how how embarrassing it can be if you actually needed to pass a confidential message across. But with things like shortest path routing within routing algorithms, we are now able to remove this circle, which is the barrier, and we are able to communicate directly to B. And think of this part now, this part to B as your telephone. You can easily just pick up your phone today and say, okay, Shemilore, you took my pencil yesterday. Where's my pencil today? You have not brought it back. Simple and short, it's just a straight connection between you and B. So shortest path routing is just a means of direct connection. As in, how do I get to this destination fast? That's just the basic thing in shortest path routing. So if you can see, there is a direct line from A to B. And if I were to communicate to D, that's this particular D, you'd observe there are 3 Ds there. But this particular D, that's D3. I can just simply go through B and then come down to D, because that's just the connection of the router or the hub. Router, let me be specific about that. Router or switch. My device is device A. I tell router B to send a packet to D without having to go through all that long infinity loop. And you can see that it's just, the cost of that transport is just 3. It's just a three method, a 3 cost. Let me just use cost there. So that's for routing algorithms. Okay, let me switch to the course material. What I want to talk next is asynchronous transfer mode. And this, from what I've seen, it's like one of the most frequent occurring questions from past questions coming from 2015 coming forth. I've not seen last year's past question, but up till 2019, that's one thing I can see is reoccurring. Aside the OSI layer, that is also something frequent. So asynchronous transfer mode, this is a form of data transmission that allows voice, video, and data to be sent along the same network. And that is what we have today. I'm communicating with us over Google Meet. I will always use that reference, yes, because that's one thing that is quite basic to all of us. So I'm communicating to all of us over Google Meet. If not for this ATM technology, do not confuse it with your automated tellering machine. You can just see ATM in the exam hall. It's asynchronous transfer mode, not automated tellering machine. Asynchronous transfer mode. It's just a form of data transmission that allows voice, video, and data to be sent along the same network. And it's, let me say, it came as a development to the ISDN technology. And it's, in a way, it's still based on the OSI layer, OSI model. And under that, we still have the switching techniques. And under switching techniques, we have 2 main types of switching techniques, which is the circuit switching and the packet switching. The circuit switching, that was the first kind of switching technique actually used. And it's mostly used within telephone networks to transmit voice and data. Voice, basically. It's until when we started doing dial-up connections that we started doing data on circuit switching. And this kind of thing, it's always synchronized. What do we mean by synchronized? I know where I am at each point in time. Okay, I'm the sender and I'm talking bit by bit, bit by bit, bit by bit. And you know that, okay, I'm counting 1, 2, 3, 4, 5, 6. I cannot just leave this sequence and jump to 50. If I jump to 50, you know that, yes, I've lost a lot. So that's one thing that circuit switching does. It takes note of the timing. And whether you use the network, whether you don't use the network, it still uses up data packets. It still uses up data packets. because it uses what we call constant bit rate. If you've attended multimedia classes, multimedia sessions within the past, you'll be conversant with constant bit rate and variable bit rate. Constant bit rate, let's say I'm transmitting data at 1 megabyte per second. I'll retain that 1 megabyte per second. Whether I'm talking, I'm not, I'll still maintain that 1 megabyte per second all through the communication. Then we come down to packet switching. In packet switching, quite different from circuit switching. It ensures that the network is utilized at all times. And it does this by sending signals even in the small unused segments of the transmission. And these are packets that keep track of time. Very, very crucial. Very, very crucial. That's why if you're watching a YouTube video and let's say your network is messing up, that's the time your network is trying to switch speeds. Let's say you're moving from a region of good network to a region of bad network. A network is trying to switch from 3G to 4G or from 4G to 3G. You'd observe this because your video will break at some point in time. That's where you have this packet switching. Okay. Okay. In transport, there are two basic types. That is the datagram and the virtual circuit. And datagram, as you can see, this is where each packet can take any path through the network as long as they all reach the destination. That's part of where routing comes in. And virtual circuit is where all packets are routed through the same path without having the path dedicated. And if you remember from our listing, from the shortest path routing diagram, you'd observe the first example I gave was the virtual circuit. That's where I said, okay, with the circle inside, that's the virtual circuit, because it must all, let's say I need to talk to D, I must always, I know, I'm always headed south, and I'll always take south. Sorry for that break. So virtual circuit is where all the packets are, they all go through one particular source. Think of this as your tap water. It only knows that particular pipe which you put. But if I have two taps, this is a pipe, I put a tap here, I put another tap here, and down here is the pipe connecting it. And let's say somebody opens this tap. The water is just looking for an exit point. All it knows is as long as the water gets out of the pipe, it goes. That's just what you have there. So understand that for virtual circuit and datagram, please. Okay. Let me come down to simplex. Under transmission technology, that's where data transmission occurs between transmitters and receivers. And the way we are talking now, let's think of it as a transmission technology, data transmission. I'm transmitting data to us, and it can be guided, it can be unguided, and in both cases, it's always a form of electromagnetic waves. So with guided media, the waves are guided along a physical path. That's example of a guided media is the fiber optic cable, the network cable, the twisted pair, the coaxial cable, and the unguided media. Think of it as your wireless network, your wireless radio, and whatever. Because you don't really have you don't have control over where this data passes through. All you know is you've put your antenna up in the air and it's broadcasting to this particular set, to this particular region. You don't know who is seeing the signal. You don't know who is not seeing the signal. But guided media, it's only where you connect. You cannot take NEPA line, go and put in your compound and put to the pole, and you expect your neighbor to have light. It won't get. But if you turn on your radio and you keep at the front, at the top of your building, your neighbor will still hear your radio, whether you want him to hear or not. So your radio is an example of a guided media. Your NEPA line is an example of a guided media. Please, let's get that. And data transmission can be simplex, it can be half duplex, it can be full duplex. And what do we mean by these terms? In simplex transmissions, the data is going only in one direction. And think of this simplex transmission as your TV. Your TV is a very, very perfect example. It's a very, very perfect type of a simplex transmission. Your TV, your GSTV, your Go TV. I believe that's all. That's the basic we have. And your radio, yes. Your radio is simplex because the data only comes in from one direction, which is your broadcasting station. It only comes from there and distributes to all. Whether you like it or not, you still receive the signal. You still receive the signal. That's for simplex. It only goes in one direction. But for half duplex, we have the half duplex connection, the half duplex transmission. And in half duplex transmission, compared to simplex, half duplex signal can only travel in one direction at any point in time. Yes, we are talking. Okay, let me say me and Mastercraft, we are talking. You would observe that for us to establish a connection, a communication, I can only talk while Mastercraft listens, or Mastercraft can only talk while I listen. Both of us cannot be talking at the same time because we cannot understand ourselves. So our basic everyday communication is half duplex. Is half duplex. Then full duplex is when we can all talk at the same time. I don't have to tell you wait because I want to talk. No. I talk, you talk. It's just that in today's classes or in today's environment, we all consider that as noise, true or false.
True.
Okay. So I want to believe that's basic for almost what we have. So remember, the desirable properties of routing algorithm is correctness, simplicity, robustness, stability, fairness, and optimality. OSI layer, please do not touch Sean's presentation application, which stands for Physical Data Network. Please do not touch transport session presentation application layers. Simple and short. And under routing algorithm, we have the adaptive type and we have the non-adaptive type. And
hello, sir.
Yes.
Please, sorry to interrupt you. Please, can you please come again with that acronym for the OSI model layers?
Please do not touch Sean's presentation application.
Okay, that's PDNCSPA.
Yes.
All right. Thank you very much, sir.
Yes. So if you are able to write this out on paper, you should be able to at least now start expanding it, because you know that the first thing for a network to flow is the physical layer, followed by the data and the network, then the transport, session, presentation, application. All this, it should be quite easy. Just look for a way to put that at the back of your mind. Or you can also formulate your own acronym, whichever way you can understand it. That's just it. But always remember the order with which it goes. It's very, very important. So, recapping, we have two types of switching technique, circuit switching and packet switching. And We have asynchronous transfer mode, which is short for ATM, which is the full for ATM. And asynchronous transfer mode, we were able to establish that it is a form of data transmission that allows voice, video, and data to be sent along the same network. And we also talked about routing algorithms, and we also talked about transmission, which is the last thing we spoke. So, is there any question before we dive into the past questions? Any question?
And I don't think there's a specific question. Can please proceed, sir?
Okay. And one other thing I would like us to put at the back of our mind is ISDN. ISDN. I forgot to talk about it earlier, but it's one of the things that come out frequently from my observation within the past questions, and that is the Integrated Service Digital Network. And what does it? It's an international communication standard for sending voice, video, and data over digital telephone lines or normal telephone wires. If you're opportune to use Nitel back in the days, Nitel back in the days, you'd be very, very conversant or familiar with this particular one, because they come to your place, connect a telephone wire, give you a modem, and you are able to communicate using this modem to do internet. And compared to today's speed, we all know how the speed back in the days used to be. When you have to simple Google page, you have to wait for about 5 minutes before it loads. You can't take that now. So do we move to the past questions now?
Please proceed, sir. Please bear in mind that we have like 15 minutes left.
Yes. So I don't know how I'm trying to. Okay, I'm trying to share the past question tab. Okay. So we can see this now. This is past question for 2019. Uh, 5 properties that are desirable in a routing algorithm. And I just talked about that. So please, can someone help us with that particular question?
I can still remember simplicity.
Yes. Any other person?
I remember it should be robust, it should be stable and optimal.
Thank you very much. Okay, so let me quickly recap that. Under desirable properties, yes?
How many, please? I just came in. What's that mean?
They said 5. Okay, you're asking what you missed. Well,
You mentioned 3.
you must have
I
missed a
was
lot.
thinking that. I said, you mentioned 3.
They said 5. They said 5.
Okay.
He said robust. He said simplicity. He said stability. So I'll recap that 5 properties that are desirable in a routing algorithm. It must be correct. It must be simple. It must be stable. It must be fair. It must be optimal, and it must be robust. So, but what they put in the course material, they use them as, will I say, verb or adjectives? I don't English, not my language. So I'll just try as much as possible. What they put there: correctness, simplicity, robustness, stability, fairness, optimality. Thank God it's not CBT, so at least we can be understood. So they said give 5 examples of of domain names. I've not talked about this, but it's very, very simple. Can someone help us with that?
I don't know if they are talking about the top level domain names like domain names ending with .com, .com.ng,
They're all domain
.net.
names.
Okay.
They're all domain names according to the course material. So any part that suffixes those domain names, it's still part of a domain name. It's still a domain name. So com,
Okay. Not
net,
the full.
org, ng, they're all domain names. And you now have things like google.com, nacosnoun, nacosnoun.com.ng, if my memory serves me right. evansng.com and co, and so on and so forth. So the user node interface exists between a single end user and a public ATM network. Between a single end user and a private ATM switch, or between a private ATM switch and the public ATM network. This can be, think of your WhatsApp. Use your WhatsApp as an example here. When you are doing video calls or audio calls on WhatsApp, you can easily relate it to that. So it's an example of a user node interface. But the network node interface, it's that one now is between, okay, WhatsApp is under Facebook, Abi. So think of that one as between Facebook and WhatsApp, because these are their servers now. So they are not really between on your side. So this exists basically between 2 private ATM switches. And the intercarrier interface, that one is mostly between network carriers. That's something like between MTN and between Glo. So that I'm placing a WhatsApp call across to you. I place a call from my network. My network now does inter-carrier routing to your own network, which is Glo, and Glo now locates you, and they are able to route it in between themselves. So that's just it. So it said describe the basic operations of an ATM switch. I think we touched that. The goals and services of the network layer of the OSI model is basically to get a standard for data communication across network interfaces. Question 2, in appropriate order, mention the 7 layers of the OSI of the ISO OSI reference model. Who can help us with that quickly, please?
Mention the what? Well, we have the
7 layers of the OSI. Yes.
We have the physical layer.
Okay, we have the physical layer.
I cannot mention it accordingly, but I know we have physical data,
network layer, transport layer,
transport,
section layer, application layer, the presentation layer.
The question said in appropriate order. In appropriate order.
The physical layer, the data link layer, the network layer, the
We have the
transport
section
layer,
layer.
the section layer, the presentation layer.
The data
If I'll quote the, I cannot even get this thing now. I wanted to see if I can quote the course material, what they said about it. Okay.
So the relationship between bandwidth,
between data rate and bandwidth, yes. So they said the concept of effective bandwidth.
Most of them.
It is the band within which most of the energy is confined, and they quoted that most. So once you get to that question, just put it. It is the band within which most of the energy is confined for bandwidth. Then data rate. Data rate. What do I have here?
You know the funny thing?
They not even define data rate here.
In the TME.
It is still in the TME, Abi.
The TME unit 2 of this course. This is going to be
this one, I think they revise these questions almost every year. Okay, we've done 2. So let's. How many questions did they say we should answer?
If it's 3 units, 6 questions. Sorry, 5 questions.
4 questions. 5 questions total.
So now they say bandwidth is what? Was the band within which most of the energy is confined, right? Confined.
Yeah.
I'm trying to explain this thing. Sorry, I'm trying to get it, so I will be able to write it down just in case. Within which
so I want to. Yes.
Well, there's this part of that paragraph. It said limits. The data rate can be carried on the transition.
Yeah.
So data rate is like bicycle and the bandwidth is like the.
That's the speed of the data transmission. Okay. So let me jump to question 5 here.
God willing.
For the sake of time. He said define the term routing algorithm. We touched that. And we were able to say that it is a part of. We were able to say it is a part of the network layer software responsible for deciding which output line an incoming an incoming packet should be transmitted on. So bear in mind, it is that part of the network layer
Please come again.
software.
It is what?
It is that part of the network layer software which tells us which line an incoming packet should be transmitted on. Which tells us the output line on which an incoming packet should be transmitted on. Are you typing it? So
Yes.
bear that in mind. Okay. They said describe any four fundamental differences between non-adaptive and adaptive routing algorithm. Wow. So for non-adaptive networks do not okay, thank you.